Hello, and welcome to this lecture on retail tariff design. This lecture's goal is to help you understand why energy tariffs are designed as they are. I also hope you leave with an ability to compare tariffs based on their design principles. We'll also review the role of infrastructure limits, that is, how smart meters impact tariff design, and also demand response, that is, how considerations for demand response are impacting tariff design. Let's first talk about electricity tariffs. Electricity tariffs define the relationship between retailers, here on the left, and customers, on the right. Customers buy electricity from the retailer, usually via subscription, buy this much at this rate. These tariffs can depend on many factors. For example, how much you consume, what's your maximum consumption peak in a given month, how many cables and what kind of cables connect you to the grid, and so forth. But electricity tariffs are not so straightforward to design. There are a few principles that guide the design process. These include the sustainability or sufficiency of revenue, which is the recovery of sufficient revenue for grid operation. There's the equity and non-discriminatory access, which is ensuring equal charges for equal power consumption, irrespective of who the user is. Then we have economic efficiency, which is allocating resources to those who value them most. In free market systems, this is usually ensured through pricing at marginal costs. In non-market systems, such as monopolies, economic efficiency is often maintained through regulation. Next in line is transparency, which is clarity in the tariff design process and its outcome. A closely related principle to this is simplicity. That is, tariff designs are easy to understand and react to for subscribers. Stability means less divergence of tariff design, which is the tariff formulation, across billing cycles. It also refers to the stability of the tariff charges themselves, which are the values within the formulation over time. Consistency with a larger regulatory framework is ensuring that the regulation of the electricity sector is, for example, not at odds with regulation in other public goods. Lastly, additivity of cost elements is ensuring that the final charge equals the added sum of each tariff component. These are the main principles that retailers and regulators try to adhere to when designing tariffs. But it's impossible to adhere to all these principles at once. Sometimes you have to make a complex tariff, which is no longer simple, to make it highly efficient, for example. An additional consideration for tariff design nowadays is demand response. Demand response is the change in consumers' demand when they observe a higher or lower price. For electricity retail, industrial users have had high demand response since their electricity bills tend to make a large chunk of their costs, and/or they can move around easily to other locations, and/or they can install their own generators if it's cheaper than the grid. So retailers tend to price them differently, in ways that maximizes benefits from demand response. With demand response, the retailer can sell electricity when it's cheapest on the wholesale market, and they can also reduce network costs by reducing grid peaks. These savings lead to more overall welfare. With more smart meters, better price signals can be sent, which leads to more demand response. Speaking of smart meters, we need to acknowledge a physical limitation for tariff design. Tariff designs are limited by what they can actually measure, and that depends on what kind of infrastructure we have in place for measuring. Electricity meters differ a lot from the traditional meters that only give you how much is consumed over a long time period to very precise IoT meters that communicate rapidly via the internet. It is worth noting, however, that this metering infrastructure is usually in the hands of the grid operator, whereas the tariff design is usually the retailer's business. These two entities might not be the same, and they might have different incentives in place. Smart meters and the infrastructure that supports them have become much cheaper in recent decades, so more and more regions opt to install them. The consequence of this is that new tariff designs are now being used in the electricity grid that are, in principle, better than the old tariffs. If the grid operator does choose to install smart meters, we can use many new tariffs that give better information to both retailers to adjust to retail operations and to consumers to adjust to consumption decisions. Examples are real-time pricing, where electricity prices follow their true value, more expensive when electricity is scarce and cheaper when electricity is plentiful. Then there's critical peak pricing, where electricity prices spike at the worst moments of scarcity, or when the local or regional network experiences congestion. Demand charges also, where electricity network costs follow the highest use in a given period, so a user pays precisely for the cables and transformers used to deliver electricity to them. One of the main benefits of deregulation has been that many new tariff options have started being offered in many places around the world. These offer a limited example, but there are many others that can be reviewed by doing a quick search on electricity tariffs. There's also an entire world of what kind of tariffs to use for renewable energy. The key takeaways from this lecture are: tariffs are designed based on principles that are difficult to meet at the same time. Tariffs are limited by metering infrastructure. With smart meters, we can design many new tariffs. Demand response is an important aspect of modern tariff design. Deregulation has made it easier for new tariff designs to appear in new places, such as real-time pricing, critical peak pricing, and demand charges. To learn more about these topics and more, I recommend these papers. The Renaces and Ortega paper discusses tariff design from a theoretical angle. The Allahakun and Yu paper talks about smart meters and their role in future energy systems. There are also many other papers and studies about tariff design that can be found by checking the citations of the Renaces and Ortega paper.